In episode 8 of Mobycast, Jon and Chris discuss the core AWS services they use regularly. Welcome to Mobycast, a weekly conversation about containerization, Docker, and modern software deployment. Let's jump right in.
Today, we're just going to talk about some of the services that we use and love. We've already talked about one of them in depth in episode 3, and that was Amazon's Elastic Container Service. And we'll just redefine it here today and give some quick highlights about what it is and why it's good. But definitely go back and listen to episode 3 if you're more interested in the details of ECS. What is that though, Chris? And why do we use it? Why do we love it?
Yeah, so ECS is definitely one of the foundational AWS services that we use, since we are fans of containerization, and we Dockerize all of our apps. So ECS stands for Elastic Container Service, and what it is, it's a container orchestration service for scheduling, running, monitoring your containerized applications across a cluster of nodes inside your Amazon cloud. So really, this is the go-to service that we're using on a daily basis, right? Whenever we're doing a deploy of our code, we're using ECS. Whenever we're launching a new application, we're using ECS. When we want to see what's going on, when we have to troubleshoot, we're looking at ECS as well. So it's definitely it is in the wheelhouse for us, given that we are big fans of containerization.
And just to kind of counter that to what we could be using, we're using ECS as opposed to, say, just spinning up individual machines on EC2 and installing our software there and managing it there, or installing our containers onto those individual machines and using some other orchestrator like Kubernetes. And we're using ECS in place of doing a platform as a service like Heroku, or doing a platform as a service like Elastic Beanstalk. And in fact, we do not like Elastic Beanstalk. Let's talk about Elastic Beanstalk a little bit and what it is and why we've moved away from it. There's a few applications that we used to have on Elastic Beanstalk, and we've pulled them out of there. What are some things that we don't like about it? Or what is it first, Chris? And then what are some things we don't like about it?
Right. So yeah, Elastic Beanstalk is kind of in a way, it's a precursor to ECS in that, but it's at a higher level of abstraction. So it really does kind of fall into the PaaS category, so the platform as a service. And you can kind of think of it as that where ECS is dealing with units at the container level, things like Beanstalk are dealing with things at the VM level. So it's a much larger unit of granularity. And so it definitely, when Beanstalk came out, Beanstalk's been around. It's a pretty established technology. It's been around now for probably at least 6-7 years. It's been around for quite some time. And it definitely, at the time, it was definitely a wonderful tool, right? It allowed you to really easily spin up the resources that you need in order to run your application. And it served a really valuable purpose.
And Chris, I think that one of the things that at the time Elastic Beanstalk offered that its competitors didn't was the ability to get in and touch the machines that your platform as a service was running on. So the obvious competitor to Elastic Beanstalk is Heroku. So people that have used Heroku know what that is. That that you send your code to Heroku and Heroku just spins it up and now it's running and you can access it in a browser. But you can't, if you want to look at logs or if you want to do anything, you have to do these specialized Heroku commands to get access to anything. And you also have to connect additional Heroku services to see anything. So Elastic Beanstalk was sort of a step in the right direction from that, where it was like, well, it's really hard to troubleshoot and monitor on Heroku. Can we just get a little more? Can we see these machines? And with Elastic Beanstalk, all of a sudden you can turn them on, turn them off, see them, SSH into them. You just got a lot more control, and it was sort of a wonderful step forward.
Yeah, and it's actually kind of interesting because I think this is actually probably another kind of full discussion we can have about just like Amazon's approach to building products and services as opposed to everyone else. And like for me, like a really great distinction is like it's Apple versus Amazon. Apple is the full up polished, make it as simple as possible, give you one knob, right? That's all you get to turn. And Amazon is like, you know what? There's no common UI or UX. Every team, they get to design whatever it is they want. They're not gonna do, like the best job in the world at it, but they're gonna give you just the raw capabilities, right? So it's kind of like the raw. It's more of like just here's the raw tools, do with it whatever you want, and we're gonna give you like 19,000 knobs. Versus Heroku was absolutely more of like here is like a finished product / service with just a few knobs, and for some people that was probably a great benefit, and for other people like what you point out, like it's frustrating because you actually want to get under the covers and do other certain things.
Right. And another analogy that I like here is this is maybe a funny analogy, but have you ever heard of recombinant cuisine? It's like a Midwestern invention.
No.
That's when you have things like hot dishes that inside the hot dish, the ingredients are not whole food ingredients, but rather, created food ingredients. So you might have a hot dish that has tater tots in it, or it might have ketchup in it, or it might have, cream of mushroom soup, or just various things that are already their own food put together to create a new food based on other created foods. So the analogy then goes, Elastic Beanstalk is a recombinant cuisine of EC2 and all these other Amazon services. So that when it's all stirred together in this final hot dish, you still get access to the underlying services. So you can still see the EC2 instances, or you can still see the security groups and everything else that's kind of built up to create this sort of meal for you.
So I will forever now associate Beanstalk with tater tots.
There you go.
Okay. So yeah, and then maybe the other thing to add with Beanstalk is again, it's basically virtualizing at the VM layer and not at the containers. We've had long discussions about VMs versus containers, and so it's
specifically that was our first episode. Now we can get a little self-referential. So in episode 1, we talked about that.
Right. So go back, listen to that one, because that's really like the analogy here is, ECS is for containers and Beanstalk is for VMs. And so I will say, us internally, we had been building all of our apps using Beanstalk when I first came on board, and because we weren't yet using containers, and again, worked well, but it's also pretty wasteful, because if you want to have like 2 instances of your app running for redundancy, that means that you're spinning up 2 separate EC2s that are dedicated solely to that app. You can't really run anything else on those EC2s. And so we had, many additional EC2s, which meant we had issues to deal with, like, okay, what happens when we have security patches that are out that we need to get installed? And what happens when we're look at our monthly bill that we're paying for, and just other security issues, security groups, making sure that everything is locked down, and just much more difficult, much more complicated, much more expensive to operate and maintain and to monitor. So moving from that VM as the unit of deployment to containers was just a huge improvement for us. And so that's definitely kind of, Beanstalk is just really no longer part of our tool set. We've switched over completely to ECS.
Yeah, I think there's 2 other things about Beanstalk that really drove us away from it and towards ECS. And one of them is, you mentioned security a little bit. Security is always a rabbit hole, but I believe that Beanstalk has a tendency to create this proliferation of security groups. Especially if you use the console for creating your Beanstalk applications, it automatically creates security groups for the instances to talk to each other and to talk to the database. And the next thing you know, you have all these rather anonymous looking security groups in your AWS console, and nobody knows what they're for. And if you have several applications running, then you just end up with legacy security groups.
And all the security groups are all called like Launch Wizard or something like that, right?
Yes. So that's a real drag when it comes to Elastic Beanstalk. And I should say, we're AWS partners at Kelsys, and I don't know if we're allowed to talk negatively about AWS services. We might get a cease and desist from saying these bad things about Elastic Beanstalk. But then the other thing about Elastic Beanstalk that's been a drag is there's a little secret that happens that if you use the console, which why wouldn't you use the console to create a new application? Like why would you do it a hard way when there's this easy way that they make available for you? And you use the console and you let the console create a database instance for you, you end up in a world of hurt. What is that world of hurt again?
Yeah. Well, so if you can, Beanstalk makes it very, very simple for you to, as you're spinning up your application, to say, I have a database associated with my application. Go ahead and create that for me as well. So super easy to do. Boom, you're up and running. Everything's working perfectly. Then down the line, you say, I'm going to create I don't need that. I'm going to migrate my application. I'm going to build a new version of this application. Maybe we're going to port it, right? Or maybe we're doing some refactoring. So we want to break it up into 2 microservices instead of 1 monolith. So we have we're breaking it up into, a Python app, the Django Python app into 2 node services. So we're going to delete that Beanstalk application and bring up these 2 new ones. But we want to keep the database, right? We don't need to change that. That's all of our data's there and whatnot. Well, if you had Beanstalk create your database for you, when you go and delete that Beanstalk application, what else is it going to delete? Your database, right? So not a good thing to do. So that's definitely, big lesson learned, big gotcha is don't let Beanstalk build your database for you. Instead, you need to create that separately, do it yourself in RDS, and then just update your application to say, like, here is my connection string. Here I'm going to go talk to this RDS instance. So keep it. Don't let Beanstalk touch your database.
So throughout all of this, it seems like not only is it that we want to use ECS because it lets us use containerization, but Beanstalk, with all of its great things that it did in order to enable us to see what's going on inside of our platform as a service, it came with some opinionated UX type stuff and an opinionated architecture and opinionated design that ended up biting us. And even if it wasn't for the fact that containerization offers this great way forward, we'd probably still be a little unhappy with Beanstalk.
Yeah, we'll say one other kind of thing that just does come to mind with Beanstalk is kind of a chalk up another one in the con column, if you will. So you guys remember Spectre Meltdown?
Yes,
the big hubbub with that a few months back, and where we, all of our OSs had to be patched in order to deal with that and plug those security holes. So Amazon, they almost immediately had patches for the Amazon Linux AMI, and so on our ECS cluster, where we had most of our software running, it was literally all we had to do was just go change the launch configuration inside ECS to say, hey, here's the new AMI I want you to use, and then we just cycled through our cluster EC2s and terminated them and let the autoscale group bring up new ones with the new AMI. So literally took minutes of time to go through and patch all these instances. We have one legacy Beanstalk application, and that particular one, it was much more difficult. And actually there was a lot more latency associated with how soon we get that patched. Because with Beanstalk, it's not the straight Amazon Linux AMI that it's using. It's actually the Beanstalk version of it. So they didn't have a patch for that right out of the gate. And not only that, there's 2 ways of getting patches. You could do it manually. So you could log in the machine and figure it out or you could do it manually through a lot more effort, or like the preferred way is to let the managed updates feature of Beanstalk handle this. So you can define a maintenance window of when you want to receive updates and whatnot. But again, the point here is that I think our Beanstalk application, it took like a full week before it got patched for the Meltdown Spectre vulnerabilities, versus our ECS machines were patched darn near immediately.
That is awesome. That was a super cool thing that ECS made possible. So I know, Rich, that you're, in your business, neither of these are coming up for you that often, but I'm curious, as we talk about AWS services that we use that are indispensable, are you in your business using any AWS services? And if so, what are you using?
So we are using AWS, but not directly, right? So the services that we use AWS. Our hosting provider, okay. WP Engine, everything's on AWS, but we don't actually interact with it at all.
Right on. So, you have these managed services or software as a service services that you're taking advantage of. It would be interesting to know what they're using. And my guess is a lot of them probably still haven't made the shift to containerization and maybe using things like, Beanstalk or, straight EC2 instances that they manage themselves.
I'm not even really sure, but I know that they're pretty transparent about it. So I'm just quickly seeing if there's anything in here that might tell us that. But
that's usually, yeah. I mean, they may be transparent, and they may say, these are the regions that we use, or these are the, this is where the stuff is, and this is some of the stuff that we do to make sure that things are redundant and things don't fall over. But they'd be unlikely to. I would guess that they probably wouldn't get that much into the, here's how the sausage is made.
Right. And they're not actually saying anything on their website anymore. We have used S3 for storage directly, but that's rare because we can just fire up a CDN with WP Engine. I'm not sure where that is. I think it's like NetDNA or something like that. So yeah, I mean, I played around with AWS in the past when I had to, but only S3, I think, creating buckets and stuff like that.
Yeah, and that is kind of telling. It does suggest that as much as AWS may want to try to move, I don't know which direction this is on the market, but move towards more usable services that aren't totally engineering, they're not succeeding. So they really rely on the likes of companies like WP Engine or Heroku, for example. I'm sure Heroku is probably actually using AWS under the scene to create services that non super developer types or software engineers can make use of. But there are definitely, in the list of services they have, there are definitely some that are targeted towards companies like yours, and you're not even finding out about them. Interesting. Okay, so the next one I have on the list here is RDS, and it's almost even funny to talk about it because we've been using it for years and years and years, and it's like, is there even an alternative? RDS is just so fundamental, but maybe we could talk about it a little bit. Do you have anything you'd like to mention about what we like about RDS, Chris? Yeah,
I mean, we could probably just define what it is first. So RDS stands for Relational Database Service, and so what it is a managed service providing relational databases in various flavors. So things like Postgres, MySQL. There's an Amazon, its own relational database called Aurora. They also offer Microsoft SQL Server as well as a hosted MariaDB, and I believe Oracle as well. So a bunch of different flavors of relational databases, but the really great thing is it is managed. So you don't have to manage the servers yourselves. Amazon is doing that for you. It provides very great support and super easy to do things like backups and restores. It supports availability and fault tolerance features like multi-availability zone configuration just with a mouse click. So if you have any kind of need for a relational database, you have to look like definitely have to look at RDS, and there's got to be a super good reason why you wouldn't use it. You just get, there's so many benefits to it. It's kind of just, it's almost like it's the responsible thing to do, as opposed to running this stuff yourself. So you could certainly do that. You could spin up EC2s and install Postgres on them and run it yourself, and it would be cheaper. But you're kind of assuming so much risk and responsibility and liability by doing so, and it's just a hassle. So why would you do that? So RDS is definitely one of those core things that we use with basically every single app we write.
Yeah, I'm thinking back to 2001, setting up some databases for some major clients like Lowe's and Sears, and doing things like, gosh, I remember doing things like vacuum was the command we used to do on databases, and reindexing. I don't think you have to ever think about that stuff anymore with RDS. Is that right?
You still absolutely have to deal with like the application level stuff. So yeah, you will define your indexes and you'll tweak and tune them and look at them from a performance standpoint. But you don't have to worry so much about definitely don't have to worry about the hardware.
What I meant. So yeah, absolutely, like setting up your indexes and making sure your queries are performing and all that. But there used to be some just maintenance commands that you had to run on databases. And one of them was vacuum and another one was reindex. And what reindex did was just go through the database and make sure that all your indexes are up to date. And what vacuum did was, kind of the same thing as defragging a hard drive, kind of reconsolidating all your data and moving it into nice places and getting rid of gaps in your database from deletions and things like that. So I don't know if those have just been replaced by better database engines or if those have been replaced by, managed services like RDS.
I think it's definitely the former. I think it's
okay.
Just like we don't really have to defrag our drives anymore. And
just the engines themselves are better.
Yeah. And not only that, there's frequent updates and patches. These databases are being patched. So that is something that you do get with RDS, right? You don't have to install the patches yourself. You can define those maintenance windows and RDS will do that for you. So that kind of maintenance is definitely provided for you. But yeah, I think it's definitely, there was a lot more pain 15 years ago with just keeping things up and running, for sure, doing those things. And there's less of that to do now, although it's been replaced by other things that we have to do.
Right. Cool. So moving on, the next one we have on the list is API Gateway. What is that?
Yeah. So this is essentially a front door to that. It's a front door service for API calls, and you get some kind of like common core functionality from that right out of the gate. Things like if you want to do like throttling and quotas and kind of like just capturing just raw metric, just understanding the raw metrics of how many times your APIs are called. It gives you the flexibility of how you want to route those API calls. So like if you want to, if you're completely, I think a great example of this, and I think we're going to get more into this later, is, serverless is definitely a pretty hot topic nowadays. And Lambda is one of those serverless technologies with AWS. So there's it's very much possible for you to write your application completely serverless. You can write it as a suite of Lambda functions. But then the problem becomes like, well, how do you invoke those Lambda functions from the outside world? What if I have like a mobile application and I need to invoke these things? Like, how is it able to discover it and talk to it? And that's where something like API Gateway comes in. So it's that front door. It's internet facing. It's got a DNS name, and your mobile app can go and make its call to it. You define your application endpoints in API Gateway. And so when these requests comes in, it sees them, and then you tell it how it wants to be routed. So you can say, hey, when someone calls the, get messages endpoint, it knows to route it to this particular Lambda function and invokes it, and then it returns back the results. So it's definitely a key core piece of the serverless puzzle of building out an application that way.
So, and I don't know how we're using it. Is that how we're using it, where we have serverless Lambda functions and we're fronting them with API gateway, or are we sending API gateway requests to ECS?
So total truth in lending disclosure here. We are not big users of API gateway. We actually have just started to use it because we've just started to have other applications that we interact with that are being built with some of the serverless technologies like Lambda. And so we're now, we're basically we're consumers of API gateway. The alternative to API gateway is, having elastic load balancers fronting your applications, and you assign the DNS names to your elastic load balancers, and those are the front door into it. And then whatever kind of value-added services you need on the actual API itself, you would roll your own. We have not had a huge use case scenario for doing things like throttling. We usually implement our own user identity stores, profile stores, and whatnot. So using API gateway in that way hasn't been really on our radar. But as we go forward and we look at some of these newer technologies and kind of where it makes sense, we're definitely going to be looking at using API gateway more for if we do start doing more serverless, more Lambda stuff.
So a takeaway from me on what you're saying is that when we use technologies like Node.js's Express framework, or when we use Ruby on Rails, those technologies come with a routing layer already. And you can just send any, as long as you can get to that routing layer, the parameters or things that, after the slashes in the URL, the routing layer takes care of that and then gets it to the right function within the Node application or the Ruby application. But when it comes to API gateway, that's assuming that you don't have a software routing layer and that you're wanting to go directly to a function that's exposed via something like Lambda, right?
Yeah, that's a very wonderful way of thinking about it, because that really is like the canonical use case here is that if you've spread up your app across a collection of functions that are not part of the same application, then how do you route to them? So API gateway becomes your routing layer. So it's looking at the pass coming in, and it sends it off to the appropriate function. Versus if you are, Rails, Sinatra, Express, you're doing all that stuff in the app itself. So all the requests are coming into that one application, and then the application is then looking at the request and saying, okay, what function do I route it to? And that function lives within inside that application, not as a separate service.
Right on. So I don't know. We'll see if we ended up doing more serverless stuff. And that actually was the next talk. The next part of this talk is just, what do we like about Lambda? What do we dislike about Lambda? You've already defined Lambda as this thing that's lets you write a function that lives in the cloud, and the function can just be called from anywhere. And then it does its job and returns its answer. If it was a silver bullet, I think we would have jumped right on it and be using it for everything. But I think that it comes with a few drawbacks that cause us to still use applications and frameworks instead of doing serverless everything. So maybe talk about some of our experience and some of our hesitation around jumping on the serverless bandwagon.
Yeah, so I definitely have mixed feelings on Lambda, and mostly from the standpoint of it changes you to really, it causes you to change the way that you write your software. So you're basically breaking it up into these chunks that are kind of standalone, and that just and they're deployed individually. So like you're breaking up your cohesive application into a series of functions essentially, and each one of those are kind of like atomic units. And so to me, that just it feels weird and kind of like it kind of takes away some of the joy of the craftsmanship of kind of putting together a cohesive application. So that said, definitely there are great uses of Lambda, and mostly like for me, like the areas where for me it's like a no-brainer to use are when I have events that I want to respond to and take some kind of action, or I can use them as like middleware to glue together these events from one system to another one. And that's where I'm super excited about Lambda. So it's really like I can't imagine right now saying like I'm going to go and architect a complete full up application using nothing but Lambda. Like I just don't see that happening. But
and I think one of the reasons that doesn't feel natural is in part because I don't think Lambda gives you lots of organizational capabilities. So, an application, a lot of times it has a purpose, and there may be many functions that it can perform, but those functions are probably related to one another, and the overall application has a purpose in life that it's trying to accomplish. And if you have multiple applications, each of those might have different purposes. And I don't know that there's a way to show that in Lambda. Like, here's my different applications with their different purposes, and I can keep them separate, and I can look at them individually. I don't think that Lambda supports that kind of breakdown of that sort of ontology of software. I think it's just a list of functions.
Yeah, the tools are getting better. And so there are frameworks now that kind of help manage the stuff and to make it so that it's more seamless. There are things like CloudFormation can help you on this as well, to kind of like hide some of the fact that all this has to be broken up into individual things. At the end of the day, Lambda function is just code, and actually the code can be as big as you want, right? You could 8 megabytes of code. So you could actually like whatever common libraries you need in order to do what it is that the Lambda function is to do, that can be included with it. There's duplication there, but kind of like, okay, so like let the tools and the frameworks handle that for you when it's doing the deploys and whatnot. So there are ways, the tools are making it easier, but yeah, that fundamental issue definitely still applies. But I think there's definitely really good use cases for it. Things like, I'll give a couple examples. So one would be DynamoDB is one of the NoSQL databases that Amazon offers. It's kind of a competitor or very similar to something like MongoDB or CouchDB. It has a feature in it called DynamoDB streams, and streams are basically just these event streams of whenever mutable operations happen on that database, right? So they stick around for about 24 hours and then they fall off. But so imagine like in your application, you want to know whenever one of your database objects is updated, you want to let's just say you want to send an email or something like that. So how would you do that? So, normally you might say, okay, I'm going to update my application. I'm actually write code in my application so that in the code that handles these update requests, in addition to making the update on the database, it also then does something else to send out this notification that the update happened. But in this Amazon ecosystem, what you can do is you can set up that stream, which is basically just a one click on the Amazon console, and then you can then have a Lambda function subscribe to that stream. And so whenever there's an event on that stream, your Lambda function gets called. And now that Lambda function, so you can basically have that logic of, hey, I want to do something when this event happens, just with a very simple function handler that is implemented as a Lambda. And now you've decoupled that from the rest of the application. You don't have to redeploy your application to get that functionality. You can keep that very loose coupling. and have the flexibility to do whatever it is that you want. And so if that changes where you want to now do two types of notifications, it's very easy to do. You just update your Lambda function. So you can have a handful of these Lambda functions in conjunction with your main application, and together have a very powerful, flexible system that it makes it really easy to add on some pretty sophisticated features.
Yeah, that is a good use case. Another one that comes to mind is sort of cron type things that happen maybe infrequently. One that we did recently was reading some Medicare data from the Medicare government website once a month. And we could have, of course, made a Docker container and put a task into ECS that could have been triggered from CloudWatch, triggers that happen once a month. But it's just way less setup and way less work to create a Lambda function to do that. And the result is essentially the same. Something that gets called, a function that gets called and runs quickly, and then it's done. Just to share a quick story, one of the things that can be a drawback, I think, on Lambda is that it's a little bit difficult to monitor. You can't really see, especially if you have a lot of traffic going into your Lambda functions, and they're sort of making an application that's ongoing and handling, many requests per second all the time. It may be difficult to really get a lot of insight into what's happening. And we know that under the covers, Lambda is using containerization, and it's spinning up containers and discarding old containers and trying to shape its capability to the traffic that it expects to see and that it is seeing. And at one point I was at a conference, and a person that was giving a talk was talking about how they've done some reverse engineering to find out what Lambda is doing and how often it's getting rid of old stale containers and spinning up new ones. And there's when you're running a high load application in Lambda, there's some evidence showing that occasionally there would be slower requests while new containers are starting up and becoming available. And they had just done a lot of graphing and mapping to figure out what really is going on under the covers. And at that conference, in the audience was the general manager of Lambda from AWS himself. And it was interesting just to see him kind of nodding along and at the same time knowing that some of the things that were being shared were reverse engineering of the secret sauce of Lambda that he probably is not really allowed to talk about publicly. So it's just a really fun interaction to see. But at the end of the day, my takeaway was, to be a little bit careful in terms of doing large applications at scale inside of Lambda, because your control is not, you don't have 100% control over how things happen, and your ability to monitor is a little limited.
Yeah, indeed. And definitely in the past, that spin up time was definitely a huge factor, because the spin up time used to be a lot lengthier. So it would be like if your Lambda hadn't been invoked for a certain amount of time, then basically that would be deprovisioned.
Right. And
then the next time a call was made to it, there was some startup initialization time. So it could be, a lengthy, 10, 15 second delay before it actually responds to that call. And then after that, it's like the normal quick response time. So you end up doing things like, I'm going to set up, some other like cron job or Lambda, some scheduled task that goes and just hits my service, my API every minute or every few minutes type thing to keep it warm.
Yep. Well, cool. I think, there's so much to talk about in serverless, and clearly we're interested and excited to talk about it more, but we were wanting to keep this conversation at a fairly high level across a lot of different AWS services. I think we have time to touch on just the last few, and maybe we can touch on them. Oh, there's actually 4 more that we wanted to talk about, so it's going to be difficult to get to all 4. But maybe we could we could leave out S3 and instead just talk about SNS, SQS, and SES, just briefly what those are and why we like them, why we use them.
Right. Yeah. These are some of the core messaging services that AWS provides. So SNS, that stands for Simple Notification Service. And what that's for basically you can set up these they're called topics, which is kind of like, you can think of it as just a channel. And then you can have basically pub sub to that channel. So you can publish a message to that channel. You can have 0 to N subscribers to that topic that are then notified when a message is posted onto that, and then they can read that message and then do whatever it is. So it's this multi-reader events channel, if you will, type thing. And you can use this for a variety of use cases. You can use it for things like sending push notifications to mobile devices, whether you're using Apple's APNS or you're using Google's, I forget, GCM, I believe is what it's called, for push notifications to Android devices. You can set up these messages to go to various different places, whether it be like queues, or you can chain them together to say trigger an email or something like that. So pretty flexible.
Yeah, and that's been the most interesting thing to me about SNS, is that really when we started with it, we thought of it as, that's what we use for push notifications. But now it really seems more like a full-on pub sub, publish, subscribe bus.
And no, what it is it's one of the really great use cases of it is just this concept of fan out. This might be a good segue into SQS. So SQS stands for Simple Queuing Service, Simple Queue Service. And so what that is basically, it's just a message queue, right? You push a message onto a queue, and then you can have readers that are just pulling messages off of it. And when a message is pulled off, then it's only that whatever pulled it off is the only one that can see it, right? So it's not this one-to-many publishing. It's basically just one-to-one. Whoever gets the message does it. So you can think of it as like just units of work, as opposed to kind of like notifying a list of subscribers. So like a really great example of how these two things interact is recently we were using SQS to trigger one of these we would send in a message to an SQS queue when a certain event happened, because we wanted to take a specific action when that event happened, right? So we would basically publish this message to the queue. We'd have the one subscriber to the queue reading from it. It would pick up these messages and say, okay, I'm going to go do my background task on it. And it worked very well, did exactly what it needed to do. But then we had the situation where it's like, oh, we have this other piece of software that it also wants to know when that event happens, because it wants to do some other task that's related to when that event happens. So what do we do there? So we could definitely go ahead and create another queue, and inside our code that handles the event, we could basically send two messages, one to the first queue and another one to the other queue. But that feels, duplicitous and it's error. But what happens if the publish to the first queue is successful, but the one to the second queue fails? What state are you in? So that's when we said, like, let's go ahead. This is a great use case for SNS. So instead of sending two SQS messages, let's just send one SNS message that, hey, this event just happened and here's some metadata about it. Then what we do is we can now have multiple subscribers to that SNS topic. And the subscribers can be things like an SQS queue. So now this concept is called fan out. So you basically can fan out your event to multiple subscribers using something like SNS. And so it's a very powerful tool to use, and it doesn't have to be just fanning out to SQS, right? You can fan out to a Lambda function as well. So actually, in our particular case, we're fanning out to an SQS queue as well as a Lambda function. And
just to add to, those are great reasons to use a message queue or use a publish subscribe system in general. That's what they're for. There's a lot of other ones out there, some open source ones, some commercial ones. And, I think the reason that we like to use the SNS and SQS is because we're already using AWS for other things. We know from experience that setting up and keeping running those open source ones requires work and configuration and thought and troubleshooting. And we'd like to spend our brain cycles thinking about, customer needs and user needs rather than whether or not our queuing system is running on some EC2 instance out there. So going with what Amazon has provided is absolutely adequate, if not world-class, and keeps us focused on what our users need.
Absolutely, yeah.
And also, I think the word you were looking for was duplicative rather than duplicitous, but I do like the idea of some duplicitous coding. Okay, so the last one before we wrap up today is SES. What is that, and what do we use it for? Why do we like it?
Right, yeah. So SES stands for Simple Email Service. And so this is literally a SMTP server so that you can send email messages to wherever you need to send them to. So again, another messaging, core messaging service that your apps can use. We use it to, again, trigger emails when certain events happen, or we want to send information to users of the system or whatnot. And you can, again, chain these things together. So you can have SNS fan out, and one of those things is you can trigger emails through SES when those SNS messages happen.
Right. And I think that SES honestly is a little more difficult to set up and a little harder to work with than one of its competitors, which is SendGrid. And we used to use SendGrid as our de facto email sending service. And it has more features too. It lets you, see nice reports of what emails are bouncing and manage those lists very easily within the system. And SES is a little bit more just, here's a system, use it at your peril kind of thing. And it also requires a bit more setup. They make you essentially apply with Amazon in order to be able to send messages beyond an initial small whitelist of users, which can be a bit of a pain. But the one thing that it does have is just, nice, easy integration with other Amazon services. And so I think that's one of these cases where SES may not be the best solution, may not be the most world-class one, but we kind of got sucked in to using it just through Amazon's sort of total platform capability and tie in with everything else, that lock-in that Amazon tends to do to you.
It's kind of, in a way, it's a network effect, right? It's
yes.
Like, even though it may not be as full featured, just the integration capabilities, that kind of definitely tips the tide into its favor.
How often does that happen, where you move away from a better product because of the integration that it has?
I mean, it happened there. It may have happened one or two other times. One of the things I'm thinking about is, well, like Elastic Beanstalk, I think, is another great example. We talked about that earlier today. And Heroku is a cleaner, more polished product, and it's more pleasant to use. But it left a little bit to be desired in terms of monitoring and troubleshooting that the not as good product, Elastic Beanstalk, tipped us into it because those were so important that we were willing to put up with a worse user experience.
Yeah, and it's actually the reverse is probably more true. Like, there's definitely cases where kind of like the AWS version of something is just not good enough, so we use something else. A good example for us is logging. So Amazon has CloudWatch logs. They're logs. They're rotated. They're easy to set up. They're integrated, but they're really not. I mean, they're kind of difficult to work with. They're not too developer friendly. They're not easily searchable, and so we use an external service for our logs. So we use Sumo Logic, and that's all they do, right? They focus on just logs, and it's great. And we have every kind of feature that we need, and it really helps us get our job done. And so, that's a great example of you don't have to drink all the Kool-Aid. You really have to be careful and know like what the trade-offs are and use the right tool for the job. But there are a lot of great tools that Amazon has, and a lot of times it may be not as full featured as something else, but it still covers your core use cases. And so it doesn't limit you. I think that's kind of like the big things, like how much does it limit you? And if it is, then you need to be looking to some other tool. But if it's just 10% easy, 10% better, like, is that enough to make you lose that power of integration, that network effect of staying within the AWS ecosystem?
And so in this case, SES, SendGrid isn't an order of magnitude better. And so therefore SES is the right solution for that.
Yeah, I would agree with that.
Yep. So next week, we have a couple more core AWS things that I want to still talk about, S3, and I want to talk more about CloudWatch, and then talk about several things that we're evaluating and excited about that we haven't used much. Some we've used a little bit, that we're rolling into just our main tool belt of AWS options. So I'm looking forward to that conversation. And thank you, Rich and Chris, for such a fun conversation today.
Yeah, thanks, guys. Enjoyed it.
Thanks. Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/08. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.